Today we're going to be modeling with quadratic functions. Here are the state standards for you to look through. You can see a lot of these terms show up multiple times. You're going to have to be able to interpret, create, solve, compare, represent. All of those are important terms to know about quadratic functions today. Your success criteria: you need to be able to write equations of quadratic functions using their vertices, points, and x-intercepts. You also need to be able to use technology to find a quadratic model for a set of data. Here's a couple key ideas. When you write a quadratic equation given a point and a vertex, all right, so you will use vertex form, y equals a, parentheses, x minus h squared plus k. Okay, so you've seen this before, but this is easy when you have a vertex and a point to write an equation. All right, given a point and the x-intercepts we're calling p and q, then you can use intercept form, which is this form right here, y equals a times two binomials, x minus p and x minus q, where again, p and q are your intercepts. Example 1, writing an equation using the vertex and a point. The graph shows the parabolic path of a performer who is shot out of a cannon, where y is the height in feet and x is the horizontal distance traveled in feet. The performer lands in a net 90 feet from the cannon. What is the height of the net? All right, so if you look here, you can see the graph. So this is a human cannonball. Not sure why anyone wants to be shot out of a cannonball, but anyways. So we have the horizontal distance in feet and the height in feet, and you can see that trajectory right here. So they do give us 2 points, 0, 15, and 50, 35. So we can see that 50, 35 is the vertex of this parabola. So what we're going to do is take vertex form. All right, so we have y equals a times x minus h squared plus k. So that's vertex form. And we have the vertex. So the vertex, and this is from the graph, is 50, 35. And we have another point, our y-intercept, 0, 15. So what we can do is plug that in. We know that our vertex, this is h, and this is k. So we're going to say y equals a times x minus 50 squared plus 35. And then we know that this is just another point, xy. It's the y-intercept, but it's just another point on the graph. So we can say it's just an xy that is included in this equation. So we can plug that in. 15 is our y. A times x is 0. 0 minus 50. And then plus 35. All right, so once we do that, we only have one variable, a. So what we want to do is solve for a so that we can use a and the vertex to write our equation. So we're going to have 15 equals, and then 0 minus 50 is just negative 50, and then negative 50 squared is 2,500. So we're going to have 2,500 . Let me double check that. All right, yeah, so that is 2,500. So we're going to have 2,500 times a. All I did was use commutative property there to switch the number with the variable, and then plus 35. So we're going to subtract 35. That's going to give us negative 20. And then to solve for a, we have to divide by 2,500. So a is going to be equal to negative 0.008. All right, and then once we have A, we can take A and we can take our vertex and we can plug it into the equation here. So we're going to have y equals negative 0.008 times x minus 50 squared plus 35. All right, so it says the graph shows the parabolic path of a performer who is shot out of a cannon where y is the height in feet and x is the horizontal distance traveled in feet. The performer lands 90 feet from the cannon. What is the height of the net? All right, so what we're going to have to do is plug in 90 to find the y value that goes with that. Because if we plug in 90 for x, that's going to give us our y value that is where the net is. So we're going to take our equation that we just wrote. I can read my own writing here. That's a 50. All right, so we're going to take our equation that we just wrote and we're going to plug in 90 for x. So we're going to say y equals negative 0.008 and then do 90 minus 50 squared plus 35. $90 minus 50 is 40. Now we got to square the 40, order of operations. Says we do parentheses first, so that's going to be times 40 times 40 is 1600. And now we multiply and add 35. So negative 0.008 All right, so we've got negative 0.008 times 1600 and then plus 35. 22.2. So y equals 22.2. So we can say that the height of the net is about 22.2 feet. And here it says the world record for the furthest distance traveled by a human cannonball is almost 200 feet. Can you imagine flying through the air for 200 feet? This was achieved by David Smith Jr. So that's just a cool fact. All right, next is a self-assessment. Please take a couple minutes and see if you can write an equation given a point and a vertex. So that's exactly what we just did in the last example. There's two problems here. You've got a point, which is your xy, and your vertex, which is your hk. Please take a few minutes, pause the video, see if you can write an equation in vertex form. All right, hopefully you went through the self-assessment. So -7 would be your y. Y equals a times x. X is 1. And then minus a -2 makes that plus 2 squared, and then plus 5. So plug this in, plug in the numbers, and then solve for a. So subtract 5, you get -12 equals 9a. Divide by 9, you get -4/3. A is -4/3. Plug that in with your h and k. This is your vertex form. This is a quadratic model that goes through both of these points. B part, same thing. 8 is your y value, equals a times 0 is your x, minus a negative 10 makes that plus 10 again, squared, minus 3. Simplify, you get a equals 11 over 100, and y equals 11 over 100 times x plus 10 squared minus 3. That is your quadratic equation for part B. That quadratic model, these 2 points pass through that quadratic model.